Good morning and welcome to Smartlogic's webinar, The State of Semantic AI. My name is Ann Kelly and I'm hosting your webinar today, and I'm excited to introduce our speaker, the CEO and founder here at Smartlogic, Jeremy Bentley. And I happen to know that semantic AI is a topic that's near and dear to his heart. And I've seen his presentation, and I think you're all going to agree with me about how wonderful it is. A few things before we get started. This webinar is in broadcast mode, which means all of you are muted. If you have a question, and we encourage questions, the more the merrier. Please put that question in the GoToWebinar panel, which you should see on the left-hand side of your screen. And this broadcast is being recorded, so everyone who's registered for the webinar will get playback information sometime tomorrow. A couple other things I want to point out. We have a couple handouts for you in the handouts tab. One is a white paper on explainable AI, and the other one is a case study on how a customer used Semaphore in their data fabric. And I know that these are both topics that Jeremy's going to touch on today, so be some great reading. And with that, I'm going to turn it over to you, Jeremy.
Oh, well, thank you, Anne. Well, thank you everyone for joining. Appreciate the time you're giving us here at Smartlogic. My agenda today is slightly circular. I mean that I will touch on these subjects as we go through. So it's not necessarily we're going to start with semantic AI and move into the metadata spectrum and then talk about the benefits. I'll try and bring these points out as we talk and present, and then an exploration of use cases. They will come into the color, if you like, of the conversation as we go forward, and of course any questions. I think I will be speaking for somewhere between 30 and 40 minutes, and of course, you know, questions you can't interact through this format, but the way to interact is to think of good questions, and then I'll do my best to answer them at the end. So Smartlogic's all about revealing smarter decisions. And if you think about what that means, we're really talking about data quality and data completeness. Because human beings take the decisions, but we have to reveal the information in order to make smarter decisions. We take a semantic approach to data. We're the only leader in the Magic Quadrant that Gartner published for metadata management who do that. We're in the top right quadrant. Everyone else in that quadrant takes a traditional approach. Semantics, I hope to show you, is a very good and smart way of addressing issues that actually traditional methods can't solve. The purpose of semantic AI is to decipher, filter, connect the data, and the sorts of data we're talking about is all of it really, be it structured or unstructured. Clearly, that's not an either or. It's a spectrum of data, from everything from stuff that's putting in your databases in your SQL data lakes, your data warehouses, all the way through to tweets you're getting from your customers, and a lot in between. But it's not only just data, because when we're trying to reveal smarter decisions, we have to bring in all of the data, and much of the data that informs decisions is external to your own enterprise. So it's both internal and external. I want to show you that, or at least you know, exhibit why semantics and specifically Semaphore, which is our application, it's a faster and more cost-effective route to much improved data quality. And semantics eliminates the consequences of having data in business silos. We all have data in business silos. That is a hangover of you know, the sorts of systems we've had running in our organizations since IT began. But the consequence of having them means that data is locked up, and data is very difficult to bring together in a holistic view, and semantics solves this problem. We are not saying we're eliminating the data silos, we're saying we're eliminating the consequence of them. I hope that appeals. Of course, data silos make data hard to reach and hard to trust. And so some of the use cases that our customers, who tend to be the world's most forward-thinking organizations, they use Semaphore and semantics to solve difficult data problems which are not economically solvable by traditional methods. And I use the word economically because our customers are actually calling the semantic projects that they're doing 10-10 projects. It's coming in at about 10% of the cost and 10% of the time compared to traditional ways of working and ways of developing. Of course, you can do anything as long as you've got enough money and enough programmers, but semantics is a genuinely transformative approach to data. And its job, and what we'll look at, is it's about eliminating the effect of data silos. It's about harmonizing the diversity of data sorts and types. It's about unifying data from systems spread across the physical operating environments, which now are even more complex than before, multi-cloud, on-premise, mobile, hybrid. It's about meeting demand for the real-time and event-driven data for decision-making, and it's about addressing the growth in operational analytics and business-led data modeling activities. And we refer to, the real pointer here is business-led. For it to be trustworthy, the business needs to understand it, and that's an important aspect of what semantics brings to data quality. Of course, it's semantic AI. We need to define a little bit, what the promise is, I guess. It's compelling. We would argue that it's not, and the bottom note there is the concept of an AI singularity, which is what the data scientists and the technical brilliant teams talk about as, autonomous decision unit, is still a distant dream. What we're talking about here is the ability to automate the next order work functions using digital rather than human labor. It's still transformative because it is going to affect something like 50% of the world's economy, 1.2 billion employees, if you believe McKinsey. It's delivering on the promise, it's current technology, right? That is what our focus is on. So technology that can be implemented now is proven and live inside our customers, digital ecosystems. But delivering on the promise of AI requires you've got to be able to use the available technology. That available technology demands high fidelity, high veracity data, and that data has to be placed in context to the task being automated. And if we want to automate next order tasks, those are the requirements. And when we talk about being in context, of course, AI gets its data context from high quality metadata and or unbiased training sets. And we could have a lengthy webinar all on its own about how you assemble unbiased training sets. I may even have done one in this series before about 12 months ago. Assembling training sets is not easy. And so semantic AI is actually a very useful tool because it generates high quality metadata as an output, which can be used in your AI projects. When we talk about AI, I mean, it's a very diverse geography of different meanings, everything from deep learning through to robotics and planning. And Smartlogic is well known, and we're very proud that this is the area that we specialize in. It's anything really to do with the processing of text-based data. We use a lot of machine learning. We use a lot of natural language processing. We augment that with knowledge models to deliver content extraction and classification. Any of the other things on this chart, I could happily have a conversation with you, but we're not experts in that. The reason why we're a Gartner leader is because of our expertise in the gray area. And the sorts of problems that we solve, some of the business use cases, and here's a small snippet of the sorts of things that we get up to. Everything from, our contracts reality does not line up with our CRM system data. And then you track back as to why that might be the case, you can see that contracts, which are the thing we get out if we have a disagreement and have to go to court or have to go to arbitration, those contracts rarely referred to. They immediately get marked up, usually in some low-cost center if you're dealing with lots of contracts, in a low-cost processing center, and the data that is in the contract gets marked up through a manual markup process and put straight into the CRM system data. And that's quite often where data quality starts to degrade, because human beings are not very good at providing consistent markup or metadata. Another example would be, my different systems are using different terminology. My silo that is engineering systems compared to my silo, which is marketing systems, use completely different language. And what I really need is an enterprise catalog. Of great interest at the moment, of course, and increasingly so, will be, data security. We have personal, private information, it's sensitive information. It's not always fully secure, and it's not always put in the right place. Why is that? Well, it's very easy, in fact, with your talking about structured data, to be able to identify columns which might contain sensitive information, but it's actually very difficult to identify, documents and emails that contain sensitive information because they're free format. So in all of these problems, and you'll be able to have a share of this webinar after I've completed it, you'll be able to download it. You can look at some of the other examples, but these are many of the use cases that we typically address for our clients, taking a semantic AI approach. It's Semaphore that is solving these data quality problems, and our customers are information intensive organizations across many types of industry. I wanted to introduce you now to a concept, things not strings. Until you get into, adopt semantics, all computer systems are dealing with strings, a string of text. My name is Jeremy. No one, the search engine that is storing, information about me doesn't know that I'm it just knows me as Jeremy. It doesn't know that Jeremy is a first name. It doesn't know anything about me. It's dealing with the strings of things. When in fact, as human beings, we're dealing with things. Jeremy, CEO of Smartlogic, Smartlogic, producer of semantic AI, customers, information intensive industries. These are all things. These are concepts. And of course, a concept is a word or phrase is very important. It's so that an idea can be conceived of the mind of oneself or another. It's the way we as human beings encapsulate an idea, and we call them concepts. And of course, concepts are used to communicate an idea of how something is, i.e. profits are down, or how something should be, profits should be more than 15% of revenue. So you've got this idea of concepts being either standard practice or real world. And of course, all organizations communicate using concepts. We talk about profit or the idea of an FTE. We all know what that is. FTE there's no way that a system that's not using semantics knows that an FTE is a full-time employee, and that means it's a human, and it means it's got a salary, it means it's got some benefits. Right? That concept of an FTE is only in the mind of the human until you add semantics to your systems. Now we look at relationships, and we see that relationships, of course, refer to the way in which two or more of these things are connected. And all organizations run on relationships between the concepts. Profit is up due to lower fixed costs is a couple of concepts complete with its relationship. Jane Jones is promoted to SVP. The inventory of SKU number such and such, his number is 42 things. So what we have to go from strings, which is just basic binary strings turned into alphabetical strings or of different, different alphabet strings, we need to move to things. And it's semantics which is accomplishing this, because concepts plus their relationships leads to meaning. And what really semantic AI is semantic AI is applying meaning to data using machines. And Semaphore is our AI machine that does that. I've talked about the siloed enterprise as the old way of working, but actually it's worth a little look at, because we need to understand the environment that we're dealing with when you're introducing semantic AI, and we're going to carry on developing this over this webinar. We're dealing with siloed organizations where not only is it an application that's siloed, but it's also the meanings are siloed. So if I'm in marketing and I've got a color of, and I produce cars, and I've got a particular color that marketing calls, azure, sunset red. Actually, in engineering, it's going to be given some sort of CMK coding, because that's the mix of colors that go in to make sunset red. And that ability to share meaning across the enterprise, as opposed to specifically implicit in the applications and the data with inside engineering, means that all of these silos develop, not just silos from a technical perspective, but silos from a place to go for what we mean by this idea. And the answer is semantic AI. It's putting in place, without ripping and replacing the systems that you've got already, an additional layer in between the system applications and the information services to give you a place to go to address your enterprise data in context. So the meanings and concepts and relationships are all available to whichever system that's there. You'll notice that and of course systems are always changing, always being invented. I mean, this, from the previous slide to this slide, the changes are in red, in the sense that we no longer have websites and portals, we also have chatbots. We no longer have just business applications, we also have robotic process automation. We used to do customer and business analytics, and now we use machine learning. We had enterprise search and CMS, we've now got voice to text and text to voice. It actually makes very little difference to the semantic platform. All these systems need to have a place to go for those meanings, concepts, and relationships, and that is what semantic AI platforms is offering in order to address those problems which I introduced earlier, the problems of silos, the problems of data quality, and all those things. Within it, of course, what we have, and start to introduce, new terminology. We have the idea of a knowledge graph, which needs to be managed. We have the idea of metadata, which is data about data, which is the way we could maybe have, taking an example of petrol and gasoline, and in Germany they call it benzene. But if someone says to me petrol, I need to know, and somebody in my colleague in the US is talking about gas, we need to know that those are the same things. So that metadata, which actually says, no, gas, benzene, and petrol is actually a petroleum product, that metadata needs to be hubbed in the center. And that metadata also needs to be applied. And for that, we have to use classification and language services, the ability to read, source data, source documents, source text, and to be able to apply what we know about the best practice of what we call these things against what we actually call them in our real world. And so classification is important. We also need to be able to we talked earlier about the introduction of, manual markup processes, which are very much a source of a lot of introduced data disquality, data error. Be able to extract data out of textual artifacts, be they structured or unstructured, in a way that doesn't require human beings. We need to use, digital workers who are consistent, work faster and more accurate to be able to do that markup. And for that, you would need fact extraction. And lastly, we need to integrate all of this together. So that's a very quick intro to, what semantic fits in the enterprise, what it's trying to its environment that it's trying to work in. It's trying to replace all those arrows of siloed meaning, one place to go, so that you can start to build up, if you like, not just a a fabric of all the information you've got to get 360-degree views, but also a fabric of all your meanings, one place to go as a great enterprise resource. And the sorts today, the sorts of the output, of course, of semantic AI is metadata. I'm almost tempted now to just keep dropping the word meta in data, because what the output of semantic AI is data, but it is curated, qualified data, which the technical world insists on calling metadata, which is just a way of saying it's data about data. In fact, it's cleaned up data. So I've wrestled with that one for the best part of 2 or 3 years. I keep wanting to drop the word meta in it, but the sorts of things that the enterprise initiatives that are addressed by semantic AI are very various. You know, we want to mark up our contracts, we want to mark up our marketing materials, we want to mark up our customer complaints letters. We want to mark those up automatically. When I get we want to do that without having a team of human beings staring and comparing at screens, which they're not very good at. And machines can do that. Semantic AI can do that. We want to secure and migrate and audit our content. We want to secure and audit our payments, whatever it is. We need to be able to inspect the special payments instructions inside a payment, which will be text-based. We need to secure it, migrate it, and audit it. So there's a vast sort of library of use cases which are already proven within our, many customers who have used semantics already to do a number of different things. They're stretching from, the ones I've mentioned through to, search enhancement, defining, discover, recommending, customer experience. And they're all doing this at that 10-10 rate. Compared to the old way of working. I want to talk a little bit about the content markup process and metadata, and I want to do that, and we start now moving into another side of the agenda, which was all about the, if you like, the metadata spectrum. But in order to understand that, we need to see the world through the eyes of a quadrant, be it, and in this case, it's a data quadrant. It's data that's unstructured on the left, it's data that's structured on the right, and of course it's a spectrum in between. It's data that's internal to the enterprise on the top, and it's data that's external on the bottom. And what we know about these systems is that, internal unstructured data is kept in content management systems, internal unstructured data, external unstructured information is kept in, is provided through portals. Structured data externally goes out through data services, and structured data internally is held in databases. So very easy. That's not a revelation to anybody. I think point about the next quadrant, these are the issues that we face that semantic AI addresses. When we look at the internal data that is, and the internal metadata that is unstructured, we can mainly see, you go and look at your CMSs yourself, you'll know that the metadata there is incomplete, and frequently we find that it's non-existent apart from the system applied primitives. We've been into, government organizations where the metadata on their, 40 million documents has all been structured as local government. That's not metadata that helps anybody. So we've got this incomplete, non-existent metadata in our content management systems. In our portals, we're externally accessing data provided by our partners. We know that the metadata is inconsistently different. We know, what does that mean? It means it's different, and depending on which different data portals you go to, it's inconsistently applied. So it's different, it's got many differences. So coming back to the unstructured side, most metadata today is still manually applied via a human markup process. It's subject to poor quality and inconsistency, and it's got a high cost. It's measured in SLAs delivered in days and weeks. We have many customers who send their very important, risk-taking on contracts out to processing centers, not in, in a low cost, and they're told, oh, that'll take 10 days to mark up an underwriting contract. and we'll come back to you with 40 different data types. And if you want any more, it'll take 3 weeks and you'll pay us more money. When in fact, machines, semantic AI machines particularly, are very good at doing that real time. If we look at the CMS systems, they've got system applied metadata. It's usually simple timestamps, user IDs, dates that they can, other system primitives that it can come up with, and then everything else is manual because it will put up a screen and ask the human to fill in the metadata that's actually more important. It's brittle and it's prone to silo differences. And if we look at how portals are powered by search engines get through their crawling process, they get their index strategies, they get their metadata from their content management systems that they're crawling. So if the content management system's metadata is incomplete and non-existent, the search engine's information is incomplete and non-existent. Turning our attention to the other side, looking at the data side, when we've got internal data that is structured, we know we have poor reference quality, right? The data from the different silos is the reference data is always seemingly different. Why? Because it's been siloed to start with, and then we've maybe got 25% through our master data management program, and we've got 75% left to go. So we've still got poor reference quality until we get to 100%, by which time we've got to go and repaint the Fourth Road Bridge all over again to start all over. So semantics addresses that issue as well, because you don't have to. You can start applying a layer of quality over your reference data without actually having to move your data, transform your data. And if you look at the external structured, we know if we are going after data services, the differences in metadata, they're consistently different. Unlike portals, which is dealing with unstructured data, so it's not formatted, at least the data services are properly structured. And where we can say, when I go off to supplier A, I get used to the data services that calls it this. And when I go after supplier B and they give me their data via their data service, they call it something else. And so that idea is different, but they're at least consistently different. Something else that semantic AI solves. My next point is that metadata is not all metadata is created equal. And there is a value spectrum. Quite often, when we start talking about metadata, we see that the thing that everyone thinks of as metadata is really what we call passive metadata, which is actually the lowest value. It's information about the data which doesn't change. Things like the title, the description, the type, the subject, the audience. Sometimes the audience can come from reference glossaries. Sometimes system applied dates to create a source. So passive metadata, though, is the lowest value metadata, and that's typically what most organizations start with. But they may have moved on to providing what we call at-rest metadata, which is expanding that passive metadata to add extra attributes to suit some specific use case, like protective markers or record types or compliance flags, or if you're dealing with contracts, maybe the legal jurisdiction is important. It's still passive, it's not changing, but it is, and it's at rest, but it is a higher value because it's supporting the use case. Semantic metadata it comes next, and because it's describing the meaning of that content or textual data. So things like topics or brands or teams or projects or locations. And of course, a product, when it's in engineering, may end up being called one thing, and it may turn into a brand or be associated with the brand when it gets out into distribution. So the semantic metadata, you start to see a move from passive into active metadata, where during its life cycle, this piece of data, this piece of text may actually change its description based on where it is in the process. And semantic metadata is really the starting point. Of course, Semaphore can deal with passive and at rest and produce all that stuff, but the semantic data is all about adding the meaning, and those meanings may change based on the business cycle. And that just gets faster, if you like. That active metadata is making that data management process intelligent and dynamic. It's used in operational use, it's integrated into business workflows, and it evolves as information assets pass through business workflows. Examples of that are things like export control markets, or or PII markers. And you might be thinking, well, how is PII a marker? How could that be changing? Well, let's think of a very simple example. For example, an aeroplane, which most of them are now sitting on the tarmac, but an aeroplane, when it is empty, has seat numbers that contains no PII. As the bookings come in, the airline may not apply seats to people until the last minute if they haven't bought their seat. The moment that seat is allocated to a person, that seat now is holding PII. Now, if also somewhere else you've added, maybe you know that a wheelchair has been asked for, and the wheelchair, you now have not just PII, you also have potentially even more sensitive information. So the active metadata, the description of those PII markers needs to keep absolutely in lockstep with the changing data that is going into, in this case, the aeroplane's configuration. It's not static in any way at all. And the most high value metadata that we see is the synthesized or the derived metadata. It's metadata which is, if you like, extracting from natural language text that's creating that data from source for use in data analytics. And often associated with certainly the synthesized and derived metadata, i.e. the totally marked up textual information that's gone through all of these other processes so far, often ends up being stored in the new world graph data structures. So we're already moving away from relational databases into post-relational data structures to create knowledge graphs and form a data fabric. So those are the introductions of some new words in this webinar that we're going to go and dive into more. Sometimes I'm asked, how much data is in a sentence? And this is an example of synthesized metadata, and this is 3 sentences. We've got some raw text. It's as far as just by reading it, you can see someone is reporting that there was a 73-year-old white female subject experiencing a 5-minute blackout on August the 10th while taking full night for the treatment of insomnia and nascent for the treatment of migraine. So very, health-oriented use case, but what happens? That's simple, and then multiply this by billions, because how many sentences do you have in your text or document or database corpuses? We need to turn, this is useful data, but it can only be useful data if we can go and extract it. And we extract it using our semantic integration service and Semaphore, but we end up with high fidelity metadata. Out of 3 sentences, we've got the patient's age, which is typed. We've got the fact that it's a female. You say that's easy. I could do that just by reading. That's true. But actually now we're starting to harmonize, because it talks about a white female subject, and then and of course the medical term for that is Caucasian, and we've now associated that to an ethnicity. So now we've got a label and a setting. We've now got a treatment, which was not mentioned here, but that happens to be the full night. Actually, its generic name is ezoplicone. It's got a database drug number, and it's treating insomnia. Right? We're moving very quickly, as you can see, from raw text, and we have so much of it in our organization, through to what is high fidelity data that can be used for analytics, that is harmonized, because we get hundreds of these all written in a different way, and they all need to be put into age, sex, ethnicity, treatments, events, and things. And don't think it's just for healthcare, it's for any business domain. This is an example of an insurance finding from a crash. Again, it's all text. It's stored in a database, but it's still text. And what we need to do is turn it into what it is. An AIR becomes an accident investigation report. The date needs to be pulled out. The investigation team, we've no idea what that is, but actually it turns out it's the electrical mechanical team. They found a VIN number in there. We can put this now turning what is actually a very valuable source of information until now solely addressable by human brains, using semantic AI becomes data which is addressable by machine, which allows us to automate that next order business function that we were talking about at the beginning. Not make decisions, not be singularity, but just automate that next level of clerical task, which is how IT has developed ever since it began. And that links to the sorts of business values so we have text-dependent systems, everything from websites through to business intelligence systems via robotic process automation and cognitive AI. We have text-dependent processes, research discovery, predictive analytics, knowledge management, which needs to be semantic AI'd. In our case, we need to semaphore it to create data veracity, data quality, so that the business outcomes are, better upsell, cross-sell, revenue loss prevention, export compliance, adherence, to name 3 that I picked out the slide in blue. So it's a genuinely transformative business value add to be able to do this. I thought I'd take a little bit of time just to drive a little bit backwards and think, well, we tend to think about metadata driving intensive processes. Well, how do you see it? Of course, it's very difficult when a machine is doing it. You can't see it. It's a blink on a server. But actually, how do we see our metadata? And maybe draw some parallels just by showing you the form. A typical form, in this case, I think it was SharePoint, puts it up and says, right, I've filled in all the metadata that I've got from my system, like the date it was loaded and, I don't know, the name of the person who loaded it, none of which is very useful in the search experience or the records management experience. And now I need some more metadata. And if we start adding those categories like passive metadata, at-rest metadata, active metadata, semantic metadata, and synthesized metadata, you start to see how the metadata that can drive the use cases which are on the right, everything from importing data, securing, with the ones which I also showed earlier, recording, records management, workflow, finding, analyzing. It's always a combination of these different metadatas, all of which can be produced by a semantic AI system that actually drives the use case. So when we're talking about importing, I'm going to need a content type. I'm going to need a protective marker, which may be active. I'm going to need some semantic metadata to say which region, which customer it refers to. When I'm securing my content or my text, I may need the content type, I may need the protective marker, I may need the region. When I'm doing records management, I'm going to need the region and the record type, right? Now, all of these, as you see, as I've been scrolling through, they're all coming, all these settings, if you like, possibles, when you're actually manually marking up, typically will come out of a knowledge model. So organizations that when we work with, you have your knowledge models. They're not constructed yet for semantic AI purposes, i.e. for a machine to use it, but actually the thought processes that most companies have already gone through for most of the existing use cases that you'd be asked for, because you're having to ask your human workers to do this work. The issue is it's very boring and no one does it properly because it's not suitable for the way our brains work, but it's very suitable for a machine that doesn't get hungry or have low sugar levels or get distracted or whatever, and we can work a lot faster. So typically, something like this to mark up for all of these different things, not unreasonable to think it will take half an hour to an hour per document to fully mark up, a document with 40 data types. And that's pushing it. In the semantic AI world, we have customers with SLAs of less than 400 milliseconds to do 200 data types. So we're talking about hours and days often, plus the delay of getting it to the low-cost center, down to milliseconds of response, which allows metadata to become an active instrument, not just in, say, reporting, because after the event, but actually in decision making, actually during the event, because metadata becomes a real-time asset, right? So as we move down through the pictures of, workflow, and we start to get into, the analyze. Now I'm going to come back to the analysis because it's really very exciting. The whole semantic and the analysis metadata is and the synthesized metadata gets very exciting for changing the way we deal with data, changing the way we can add quality to data. I thought about, so that's pretty much a state of the nation of semantic AI. and we've covered very quickly the use cases. We've covered it's where it's being used in the majority of cases in order to, solve and speed up and make more efficient data quality issues in those sorts of use cases. And I thought, well, how can I really talk about what's going to happen next? So I've borrowed, this is Gartner's hype cycle for emerging technologies. It was published, I think, July 2020. There's a lot of technologies here that have got no relevance to our conversation today, but there are three that I think are relevant to anyone who's interested in semantic AI, because this is a natural, certainly the natural, path for Smartlogic as we look out and build up, we look out and we're now visioneering. So I'm pleased to say that ontologies and graphs, which is basically the foundation of Semaphore, plus all the AI, NLP, and all that stuff, is getting close to the slope of enlightenment. And if you understand the Gartner hype cycle, all of these emerging technologies, you have to get into the slope of enlightenment, having passed through the trough of disillusionment, because you've just gone through the peak of inflated expectations. And that means that there's a lot of, when you're up there, there's a lot of lab experiments, but they don't tend to go commercial. Once we now are coming into the slope of enlightenment, it's definitely technology that's understood, technology where the skills are available to be able to implement it, the expectations are correctly set inside the minds of the implementer, and the slope of enlightenment means that through hard work, the commercial promise is deliverable. And ontologies and graphs are close, are there or thereabouts. Explainable AI is following, and behind that is data fabric. And we're going to talk about those now. I think before we go into that, let's talk about, I'm going to talk about those through the lens of the idea of knowledge graphs for analytics. And knowledge graphs, of course, are semantics and graphs. So Semaphore is built on a knowledge graph, is a knowledge graph, drives knowledge graphs, and they are also a major component of data fabrics. But data fabrics are lagging if you like, or they're behind in the adoption. So we'll start at the bottom part of the curve. And really, a knowledge model, which is a semantic model. Some people call them taxonomies, ontologies. Could be a list. Could be when it is underpinned by semantic AI, added to your operational graph. So that is your operational data in a graph form. So graph being a new type of data structure, just post-relational, not bounded by the schema. Again, there's another webinar on the subject if you're interested. So you put your knowledge and underpin it with semantics, and you put semantics and you over on a layer on top of your operational data, you end up with a knowledge graph. And a knowledge graph is a new way of seeing your data, where the data is marked up with the meaning, right? So that we've got everything consistently applied, so that we have harmonized, we've also extracted and we've also enriched this graph with harmonious data, which is drawing on data from many, many different silos. And it allows a new type of investigative analytics without the cost of skinning up a new data mart or database or data warehouse, spending a lengthy number of months doing extract, transform, and load, and coming up with an answer that is to a question that was posed 4, 5, 6 months ago by the business. So what we're talking about is that knowledge graphs are able to provide a very fast approach to investigative analytics, right, without the cost of the old way of working. Some of the cases that Smartlogic has been involved in is like identifying causes, symptoms, errors, and resolutions in tickets coming into high-tech manufacture to accelerate problem solving. Right, analyzing social data to determine perceptions of brand, products, and services. extracting facts from news to determine trends, predicting client behavior based on call center transcripts and client communication. When you're starting to predict the behavior on call center transcripts, not after the event, but using voice to text in line, and you can start to add suggestions automatically into the, if you like, the screen of the agent who's trying to answer the question based on what has been said in the previous 3 minutes of the call. Now we're talking customer service. So the knowledge graphs, knowledge models, semantic AI, all helping to transform many, many businesses. The second one I want to talk about is explainable AI, when we're on that curve, because I don't think it's acceptable, and I don't think many business people find it acceptable to take the subject matter expert, the business user, and then have that person having to explain their business knowledge, which is inherent in them, to a maths grad who is called a data scientist, whose job it is to tweak machine learning algorithms, and then expect that business user to when they see the results, to trust those results, because of course they aren't the people who put who tune the machine learning in the first place. The only way to have the business trust the output of some machine algorithm is for the business person to set and control the algorithm in the first place. And that means subject matter experts need to do the management of it, because they're the people with the expertise about the business. The next thing is that then when you're having to explain why a machine took a decision, we need to have it as transparent. It needs to be a white box, not a black box, a transparent box that you can see through and understand how the machine works. Because if you've got data and you put it through an algorithm and it comes out and you can see why it made that decision, it's transparent. And if 5 years later you have to be in front of a judge because you're in court trying to defend the decisions of that machine, you need it to be repeatable 5 years later, not having learnt a further 5 years worth of data all on its own without thinking, so that it will never repeat the decision that it took 5 years ago. You also need it to be auditable, so that at any time you can go and look through how that AI machine is actually doing its work and coming up with its answers and all that stuff. It's only in that transparency, repeatable and auditable way, which is the approach that we take with our semantic AI, do you actually get to explainable AI, which genuinely then adds business value. And the subject matter experts actually trust it, because they were instrumental in the controlling of, in our case, the knowledge model that drives the machine. So everything that happens here is about explainable AI, and increasingly you'll see it as a trend. I mean, the newspapers are picking up on it. I don't know if you saw what happened to our exam results for our students here, in London and the UK. But an algorithm, because of COVID, decided to come up with the exam results for the high school leavers, graduates, as they were graduating out of high school, and an algorithm decided that it knew best, and no one could explain to the children and the parents and the teachers how it came up with that answer, because it was a black box. And this idea of explainable AI and trustworthy AI is an important, aspect of AI and machine learning, which I would only ask you to, add to your RFPs if you're a customer, because this is how we've done it all along. We've done it all along because many of our customers are in regulated businesses, come under the scrutiny of either an internal regulator or an external regulator. Okay. And last, we get to a data fabric. And that data fabric is a more general concept, and it's conceptual right now. Many people are trying to say they've got one. I don't believe that they have in its entirety, but it's a more general concept architecture to abstract data in silos into a unified enterprise data set. But it does, we know, contain many of the things that we have available within the semantic AI stack. You've got your raw data, which has to be cataloged, and it needs to be marked up and metadata applied to it to make it consistent. And you need a knowledge graph, and you need a layer of integration so that your raw data is delivered to the people and systems as a unified enterprise data set. At Smartlogic, we've got many of these aspects. We understand the other bits that we need to build in order to actually call it a full data fabric. But it's a very exciting area. So in this webinar, which was all to do with the state of semantic AI, hopefully I've given you a picture of what it is, how it is currently used in normal use cases. I haven't explored any of the edge cases apart from as we move into the active metadata side. If we moved into the knowledge graph side, we have customers who are already implementing their knowledge graphs. Have many people actually assembled this all together into a full functioning data fabric? I don't believe so. Clearly, there are lots of experiments going on. We are experimenting. Our customers are experimenting. It's an interesting and very promising area, but it's the natural evolution of semantic AI, right? For customers who want to have a unified enterprise data set of high quality data, and it's going to involve already the bits that we provide. So I just encourage you to carry on using it. So in summary, organizations are solving previously insolvable problems by taking a semantic approach. It's where conventional methods fail. We're not trying to say if you can do it as cheaply and as fast with the conventional method, please do so. It stands to reason, but it's solving insoluble problems. And I listed some of those right at the beginning. And I really want to emphasize that it's semantics, because we're dealing with meaning and relationships that are intrinsic into the way the human brain works. And we're codifying those meaning and relationships into one place to do. We're putting the power of change, right, in the hands of the business. We're capturing and leveraging business knowledge directly. We're actually, particularly with the involvement of cloud, we're completely disintermediating IT, which reduces the time to, so disintermediating IT, you get time to value much faster because you haven't got to wait 12 weeks to get a service spun up. We'll do it in 30 minutes and get your subscription up and running within that sort of time. So it's very interesting that by having subject matter experts powering the knowledge models, we don't have to have technical assistance to encode that data, that meaning into the code of the program. We're increasing value by delivering data quality. And I believe that knowledge graphs, explainable AI, and data fabrics, knowledge graphs are here, explainable AI is here with us, but very few others. Data fabrics are next. I appreciate your time. Looking at my watch, I spoke for more than the 40 minutes I said.
Thank you, Jeremy. We have time for some questions. I have my first question here. So Jeremy, if you think back to slide 16, where we were talking about the types of metadata, and the question is, wouldn't semantic... Hello?
Yes, I'm going to go back to 16.
Oh, okay. The question is, wouldn't semantic metadata and active metadata rely on the quality of the passive metadata?
It can. But it can, because you can use the passive metadata if you know, for example, what your audience is. That might refer to, it might refer you to a special, glossary. But semantic metadata is more about the knowledge that you've already got inside your enterprise. So if I'm in insurance, I might have certain topics like, I don't know, tsunami risk, asbestos risk. So actually, if the document contains sufficient evidence that it's about a asbestos risk, and I'm using a specific example I'm familiar with, it may not have in its title or its description or its subject or its audience, because that was put there by a human. It may not actually have any of that mentioned in any of the passive metadata or the at-rest metadata. It may just be the content of the document. And this document might be a 200-page PDF. And it's not just talking about asbestos risk on page 99. It's also talking about the other risks that this company might be exposed to, which might involve earthquake risk. And I don't know, it might also talk about the offices in the company. So semantic metadata is about identifying the meaning of not just the document, but actually the content inside that document, which may be very big. And there's no way that any human can go through and mark up, oh, it says on page 99 asbestos risk, and there's a nice three paragraphs on the subject, so we'll focus in on that. So to answer that is, they've all got their role, and I don't want you to think that Semaphore won't provide better passive metadata and better at-risk metadata. It will, but the moment you start getting, if you like, going into the document, you can rely on the passive metadata and the at-risk metadata, give you better results, maybe, if it's good quality. But what our finding is that when you're dealing with, classic CMS systems, classic metadata, this stuff has been put there by humans or by system primitives, and they're not very useful. And it's human beings who have to go and clear it up. And when it is cleared up, the mind-blowing thought of having to go through, 100,000, underwriting reports looking for asbestos claims, because you are you're researching asbestos risks, and then thinking of all the different ways that a search engine is going to come up with that. And it may not even mention asbestosis, or it may just talk about, I don't know, some, work-related cough. All of that are ideas, right? It's impossible for a human being to do this. So it's got to be automated, and it's got to be automated using the knowledge of the human.
Okay, we have another one that says, on the slide titled Leveraging Knowledge Graphs for Analytics, you mentioned tickets. Are you referring to customer and or customer service type of tickets?
Yes, tickets, depending on what industry you're in, the insurance company call their underwriting slips, which is a ticket. They call it a slip or a ticket. Traders call their stuff tickets. But if in support, typically we raise a ticket. You would, if you got something to say to Smartlogic about the product, you would raise an improvement ticket with us. If you've got an issue with it, you would raise an error ticket. So yes, it can be. It's any kind of communication, I guess, that is formal about something.
Okay, I think we have time for one more question. And the question is, how do you include subject matter experts without overwhelming them with the noise so you get those good positive feedback loops?
That's a good question, like the others. The way we try to get subject matter experts to be part of the process is by crowdsourcing, and I use that term very loosely, but we try to get a very easy to use interface, which we happen to call the knowledge review tool, totally distributed amongst the enterprise to the business users. So it's an easy to use interface into the knowledge model that allows very rapid feedback and suggestion. We also then think that the actual enterprise knowledge model requires some governance, human curation, and that is usually with our customers, that's one or two people, not always working full time. Often that's part of their job, but they are trained information scientists, or they've learnt the role, where they're curating that model based on the feedback that has come in from the crowd, that crowd being the subject matter experts in the business. So it's a combination of good software design, the implementation of change, actually letting subject matter experts feed their feedback and have that listened to, and of course, being software, you can have one thing called many things, which is much easier these days, because engineering will always call it this, and marketing will always call it that, and finance will call it something else. And the joy of having knowledge models, managed not in an old index file system, but which is actually in a graph database, is everyone can carry on using the language that they use, but the moderator, the person can help join that circle on what is the meaning of all those three things, which are actually called three different things, but they actually all mean the same thing. So it's a combination of crowdsourcing and human curation, and we do draw the line at human curation. We don't let our machine learning go to town without having a sign-off by a human expert. because otherwise the machine learns. And as you know, with machines, or any learner actually, human or machine, everyone needs a professor to mark the papers. So that curation line is in our minds is the difference between an out of control, artificial intelligence experiment versus a controlled artificial intelligence business assistant. That covered a few subjects there, but hopefully that answered your question.
Thank you. And that's all the time we have for questions today. Jeremy, thank you so much for sharing your time and expertise with us. And thank you everyone who participated and joined the webinar today. And have a great day.
Yeah, I appreciate all your time. Thank you.